Hey guys, Ong here, back with another math video. Today we're going to be doing AMC 10A 2016, problem 20. So pause it if you need to, read the question, and without further ado, we're going to try to solve this question. So for some particular value n, when a plus b plus c plus d plus 1 to the n is expanded and like terms are combined, the resulting expression contains exactly 1001 terms that include all four variables a plus c plus done as a, b, c, d. What some positive power? What is n? So interesting. So when we look at this, we sort of want to think. When we look at this question, we sort of want to think, what's the resulting expression going to look like? Right. So let's try a plus. Let's try something. Let's try something on a smaller scale. So a plus b plus 1 squared, which is equal to a plus b plus 1 plus b plus 1 is equal to a squared plus ab plus a plus ab plus b squared plus b plus a plus b plus 1, which I think is equal to a squared plus b squared plus 2ab plus 2a plus 2b plus 1. Interesting. So what can we tell about this expression? Well, what it seems to do is it seems to first, of course, we have, since we know n is 2, in this case, n is 2, so n equals 2 in this case. It's interesting. If you look at the powers of each of the terms, we get a squared, right? Which means, and how do we get the term a squared? Well, we get the term a squared by taking an a out of this sub-expression and an a out of this sub-expression and multiplying those a's together to get a squared. We got b squared by only taking the b's out of these expressions, multiplying together. We got ab by taking the a out of this expression and the b out of this expression, and we got 2ab by taking the a out of this expression and the b out of this expression. We got 2a by taking these two and these two, and then we got 2b by taking these two and these two. And we got 1 by taking this one and this one out of the two expressions and multiplying together. So what seems to be happening is that when we have some sort of expression raised to the power of n, what the expression we get is all the possible combinations of choosing one term out of each sub-expression and multiplying those together. So totally you're going to get n terms because there's going to be n of these sub-expressions. See, there's two sub-expressions here. So you're going to get n of these terms, and each term inside the resulting expression is going to be the product of these n terms. So in this case we have a to the x, b to the y, and 1 to the z, and x plus y plus z is always going to equal to n, which is going to be equal to 2. And why is that? It's because depending on how many a's we choose, depending on how many b's we choose, and depending on how many 1's we choose, in the end we only have n total expressions, and we can only choose n terms out of each of these sub-expressions. We can only choose n terms total by choosing 1 out of each of these n sub-expressions, one term out of each of these sub-expressions to multiply. In this case, we have a squared, which adds up to 2, b squared 2, a to the 1, b to the 1, and then a to the 2a to the 1, but you have to keep in mind there's also 1 here to the 1, and 2b to the 1, b to the 1, and 1 to the 1, and then 1 squared. So in every single case, x times y, x plus y plus z, the exponents of each of the terms in the resulting expression is always going to add up to n. That makes sense, right? Like if you have a plus b cubed, we get something like a cubed plus 3a squared b plus 3ab squared plus b cubed. As you can see, these exponents will always add up to 3, because essentially what you're doing is, since there are 3 a plus b's, so there are 3 of these, You're just finding all the different combinations in which you can take one term out of each of these sub-expressions. And yeah, so that makes sense, right? So in this case, let's think about this case where let's go to the problem, right? We have a plus b plus c plus d plus 1 to the n. So resulting expression will have all combinations of a to the v, b to the w, c to the x, d to the y, and z to the z. I mean, d. Why I say that? 1 to the z. And this is what each term in our resulting expression is going to look like. And each of these terms will have the properties such that v plus w plus x plus y plus z equals n. So each of the terms is going to include all combinations, each of the terms in the resulting expression is going to include every single possible combination of where this is true. So that seems easy enough, right? Just find the total number of ways you can split up n into these different exponents, and then set that equal to 1001. That seems easy, right? Well, you have to be careful because the resulting expression that include all 4 variables. So we can all 4 variables a, b, c, and d. So you have to be careful because that means you can't the terms in the resulting expression which just are b, c, d, don't have an a in them, or don't have a b in them, or don't have a c in them, they are included in this 1001 terms, right? So this means that v is greater than 1, v is greater than 0, w is greater than 0, x is greater than 0, y is greater than 0, but z is the exponent to the 1 term. 1 can be anything. It can be greater than or equal to 0 because it has to have the 4 variables a, b, c, and d, but it's not necessary to have, like, you could have a to the n minus 3, b to the n, b, c, d, right? And that would add up to, the exponents would add up to n, and then you could have 1 to the 0. And that would still have all the variables in it. So it's not necessary that 1's power has to be greater than or equal to 0. So that makes the problem slightly harder. So it makes the problem slightly harder. How do we find the number of ways we can split n into different exponents but have this still remain true? So I want to split n into 5 numbers but to have this remain true. It's actually easier than you think. We can just use stars and bars. So say there are n stars. Since you want each of these exponents to be greater than 0, we just have to make sure that no 2 bars are next to each other. So you can't have since we want to have, of course, 4 bars, right? To divide these into 5 sectors. We want 4 bars to divide these into 5 sectors, and we don't want any of these sectors to be to be 0. That means the bars can't be next to each other. That also means the bars can't be on the edges. That means that there are n-1 spaces in between the stars. 1, 2, 3, 4. Right? n-1 spaces in between. You guys should know stars and bars, right? So there are n-1 spaces between the stars to place the 4 bars that we want. So it should be n-1 choose 4, right? Well, you have to be careful because you have to remember, I miswrote here. You have to remember that z can be greater than or equal to 0. So for convenience's sake, let's make the first sector v, w, x, y, and z. V is non-zero, which means the bar cannot be on the edge. The first bar can't be on the edge because we don't want to make v non-zero. V is the area before the first bar. W has to be non-zero. X has to be non-zero. Y has to be non-zero. But Z can be 0. So that means the very rightmost bar can be on the very edge. For instance, the bar could be here, and we could have v, w, x, y, and then z could be 0, right here. So that means instead of n minus 1 spaces to choose from, we have an extra space here on the edge because z can be equal to 0. So that means there are actually n spaces to choose from, which means that the number of combinations, number of possible terms we can get, where v plus w plus x plus y plus z is 0, and this each of the terms is like this, and v is greater than 1, w is greater than 1, x is greater than 1, greater than or equal to 1, y is greater than or equal to 1, to have at least one a, b, c, or d term in it. It's just n choose 4, because there are n spaces and 4 bars to place. So, and we know n choose 4 is 1001. So we should be able to figure out what n is. I believe in this case n is 14. You can just use guess and check, or you can just prime factorize 1001 however you want, but 14 choose 4 is 1001. So the answer is n is 14. So a plus b plus c plus d plus 1 to the 14 will give you 1001 terms in this form, where a, b, c, and d are raised to at least the power of 1. I hope you found that enjoyable. It's a pretty difficult question to grasp, but yeah, so I'll see you next week. So let's call the center point, I don't know, Q or S. We don't have an S. That means QS is, since we want this